Let's talk about some basic anti-differentiation or basic integration rules. And the first thing we'll address is what happens, what does it mean to find the integral of 0 with respect to x. And this is equivalent to the question, what kind of function has a slope of 0? And we know, because our algebra teacher was great, that it is horizontal lines that have a slope of 0. So we can generalize this to being any constant. Y equals 2, y equals 3, y equals negative 1/4, all have slopes of 0. Now we can take that to the next level, and the second basic rule would be, well, what happens if I'm taking the integral of some constant, k, so this is saying, if I had a slope of some constant, what kind of line must that have been? That would have been a first degree polynomial, k times x, plus c. Generalize this a little bit. What is the integral of 2 dx? What kind of equation has a slope of 2 everywhere? Well, that would be equal to 2x. It could have been 2x plus 0, or 2x plus 1, or 2x plus 5. All of those have a derivative of 2. So the integral of 2 is any of those, which is why we need 2x plus c. The plus c is very important to always have if you're taking an indefinite integral. The next basic rule is something you're allowed to do if you have a constant times a function f of x, or if you're able to factor a constant out of some function. To make it easier to integrate, you can take the constant outside solely on the function itself. For example, let's say we have, I can't really do an example, we need some more basic rules. Another idea is if I'm taking the integral of a function, it's really just multiple parts f of x plus g of x, line, I can take the integral of each piece independent of one another. I might not necessarily write it out this way, but I can think about it in this way. And the last basic rule, and then we'll try to put it all together, is what is the integral? Something of the form x to some power. Yeah. How am I going to address it? This is the power rule. A simple way of addressing this is I will end up with x to one bigger power, so always became something to the n plus 1 divided by n plus 1. Because when I take the derivative, I end up bringing the power down, which means it needs to get divided out since it's equal to 1. Example to try and tie the last three basic rules together. What is the integral of, I'm making this up on the fly, 4x squared plus x plus 12x. This is terribly complicated, but in a lot of detail. This is the same as having the integral of 4 x squared plus 3 x plus 3 dx. By rule number 3, I'm allowed to take that constant help. By rule number 5, I'm allowed to consider this as 3 independent pieces. Just x squared, just 3 halves x, and just 3. Multiply each piece by 4. When I do that, I know that the integral of x squared using the power rule would be 1/3 cubed. The integral of 3 halves x dx just be 3x squared, and the integral of 3 dx would just be 3x. Now it's true that I should have plus c for all 3 of those things, because there would be some constant from all 3 of them. The thing to remember is that when I add those 3 constants, whatever they are together, I'm just going to get a 4th constant. And so I could write plus c1, plus c2, plus c3, add them together to get a 4th constant, which is the idea behind everything. Or we can just know that there's going to be some constant that goes with all of these. If we go one step further, we'll end up with, by multiplying the 4 in, 4/3 cubed, 12x, plus 4 times whatever this constant is, and that's just going to be some other constant with a c for now. But that idea is important, that each of these individual pieces, when I integrated, there was some constant that went with it, and their sum is some other constant, and when I multiply that by 4, I do get some other constant. But for our purposes, at least for now, it's simply a constant. The antiderivative or integral of our original function.